Good evening, everyone. So, my next topic of discussion, which I'm going to discuss with you, is on the topic receptor regulation. And before I start my video, I want to request you, if this video is useful to you and if it is helpful to you, kindly subscribe to my YouTube channel, that is Dr. Nitika Hans Pharmacology Discussion. And now I'm going to discuss with you on the topic receptor regulation. Now, regulation of receptors can be in the negative way also, and it can be in the positive way also. First of all, when the receptor is continuously stimulated by the agonistic drugs, like it is a constant stimulation of agonistic drugs will lead to decrease in activity of the receptor. That is constant stimulation. And constant antagonism of the receptor, like blockage of the receptors, will lead to increase in activity of the receptors. And so, first of all, I'm going to discuss with you receptor constant stimulation, that is constant stimulation of the receptors. When there is increased activity of the receptors is there or by the action of the agonist, there will be some reactions, some actions will be taking place. Three kind of actions will be taking place when there is constant stimulation of the receptors. First of all, first is masking of the receptors. Masking means there will be the receptors present on the membrane will shift to the below of the membrane. They will go to below of the membrane, and thus there will be decrease in the receptor number, and down regulation of receptors can occur. Secondly, this is also reduced in the number of the receptors. This can be by the decreased synthesis of the receptors, or by the endocytosis, or by the increased degradation of the receptors. And then the third is the uncoupling of single signal transduction pathway, and this is by the G-protein coupled receptors in our body. They can be stimulated by some agonist, and when this agonist gets stimulated by the agonist stimulates the G-protein coupled receptor, there is presence of the G-protein below the intracellular membrane, and this G protein is broken down into it is consisting of alpha, beta, and gamma subunits, and G protein is broken down. When it is broken down, then the action of the agonist will come, and inside our body there is present G protein coupled receptor kinase, and when this is stimulated, this G protein receptor kinase will be stimulated. It will lead to a phosphorylation of the receptor, and then other things comes, and in our body the beta adrenergic receptor kinase is there, which is BARC, beta adrenergic receptor kinase. When it is stimulated, it will phosphorylate the receptor, and this phosphorylation of the receptor will lead to binding of the arrestin protein, which will lead to the binding of the arrestin protein to the G protein coupled receptor. So this will lead to not interaction with the G protein of the G protein coupled receptor, and the G protein will not be interacted because of the presence of beta arrestin protein, and thus there will be uncoupling of the signal transduction pathway will be there. Due signal transduction pathway will be there. And now the constant stimulation, it can be, constant antagonism. It can be when there is constant antagonism, there will be increase in activity of the receptors. This can be by unmasking or by upregulation of the receptor, or by decreased signal transduction mechanism. First of all, unmasking is when the receptors from the membrane below the membrane shift over the surface of the membrane. There will be upregulation of the receptors will unmasking of the receptors will be there. Upregulation is by increase in number of the receptors. This can be by increase in synthesis of the receptors, or by decreased degradation of the receptors. And next is the decrease in the signal transduction pathway. This is by the in our body, for example, clonidine is present. When clonidine acts on the nerve terminals, there will be it is used for treatment of hypertension. When clonidine acts on the nerve terminals, it will lead to decrease the release of the noradrenaline into the synapse, and so there will be a brake mechanism will be there, because it is alpha 2 adrenergic agonistic drug. It will inhibit the release of noradrenaline from the nerve terminals into the synapse, and when there is reduced release of the noradrenaline, that means there is a reduced release, the alpha 1 and the beta 1 receptors present on the present on the post-terminal membranes will not be stimulated, means they will be blocked, because noradrenaline, its function is stopped, because its release is stopped. So alpha 1 and beta 1 receptors will not be stimulated, and when we just this will lead to upregulation of the receptors on the surface of the post-terminal junction, that is alpha 1 and beta 1 receptors will be stimulated, and will be upregulated. And when we suddenly stop the clonidine, it will lead to rebound hypertension, because the upregulation of the receptors has led to increased activity of uh, the upregulation of the receptor has led to the increase in the receptors of the map of the receptors on the nerve terminals. And when we stop giving the clonidine, it will lead to increased release of noradrenaline on the receptors. So alpha 1 and beta 1 will be stimulated. So there will be increased hypertension will be there. Now this is in case of clonidine withdrawal. When we withdraw the clonidine, there is upregulation of the receptors, and then that will lead to increase activity, rebound hypertension. And in thyrotoxicosis also, and we give the propranolol, which is the beta blockage drug, and we just stop giving the medicine. It can also lead to increase in synthesis of the receptors, leading to increased function of the catecholamines, leading to palpitations and arrhythmias can occur. And in the receptor stimulation, there can be like action of the beta 2 adrenergic agonistic drugs in the asthma. When we give the salbutamol, it can lead to the reduced activity of the drugs when we repeatedly give the drugs in the in case of asthma. There can be reduced activity of the drugs can takes place because of downregulation of receptors, or masking of the receptors, or decrease in the signal transcription pathway, that is uncoupling of the receptors. So that's all with the with my video on the receptor regulation. I hope you understood. Thank you. And if you understood my video, kindly subscribe to my YouTube channel, that is Dr. Nitika's Pharmacology Discussion. Thank you.